Welcome to our slideshow presentation. Our aim is to get the student success in competitive examinations. In our slideshow, all the matters are given in the simple manner. All the contents in these slideshows are based on the TRB questions, GATE exam questions, CSR UGC NET questions, Jawaharlal Nehru University questions, Pondicherry University questions. In nuclear physics paper 1, nuclear physics question answers presentation, we saw the basic ideas about the nucleus, radius of nucleus, isotopes, isobars, isomers, isotones, mirror nuclei. Then we discussed about the three main types of nuclear models such as liquid drop model, cell model, collective model. If you did not watch it, now watch the both slideshows. It will be useful to you. In this presentation, we are going to see the binding energy, semi-empirical mass formula, nuclear forces, alpha, beta and gamma decay, difference between the nuclear fission and fusion, elementary particles, quarks and parity. We know that the size of the atom is very small, that is 10 power minus 10 meter. It will be approximately angstrom unit. So we can't see that atom. So the size of the nucleus is 1000 times less than the atom size. So its size is nearly 10 power minus 14 to 15 meter. So it will be very small. Nuclear mass is the sum of atomic number into mass of the proton plus mass of the neutron into number of neutrons. Nuclear mass is measured by mass spectrometer. Mass defect is defined as the difference between the calculated mass and real mass. Nuclear density is defined as nuclear mass by nuclear volume. Density of heavy element is lead. It will be asked in the competitive exam questions. So mind it. Binding energy is defined as the energy required to break the nucleus into its constituents, or the energy required to combine the protons and neutrons to form nucleus. It is called as binding energy. Binding energy is equal to delta m c square. Delta m denotes the mass defect. C is the velocity of light. Iron has the most stable binding energy, that is 8.8 mega electron volt. The mass number lies between 40 to 120. Binding energy is 8.5 mega electron volt. Radioactive elements like uranium, thorium have binding energy very low, that is 7.6 mega electron volt. Binding energy per nucleon is defined as binding energy of a nucleus by total number of nucleons in it. Nuclear stability is given in this table. If you observe it, protons are even, stability is very high. Protons even and the neutrons are odd, it will be less than the first one. Protons and neutrons are odd, the stability is very less. That's all. Formula was proposed by Weizsäcker. It is the sum of volume energy plus surface energy plus Coulomb's energy and asymmetric energy. In this above equation, A, B, C, D are constants. Nuclear forces are the strongest force in nature. They are short-range forces. It occurs within the nucleus. The value of the nuclear force is 10 power 4. Uranium disintegrates into thorium. Alpha particle is emitted. Alpha particle is nothing but helium nuclei. When a radioactive element emits alpha particle, atomic number decreases by 2 and mass number decreases by 4. It can be explained on the basis of Schrodinger equation. When a radioactive element emits beta particle, atomic number is increased by 1, but the mass number is not changed. Rest mass of the neutrino is negligible. Radium emits beta particle. It will disintegrate into actinium. When a substance or radioactive element emits gamma rays, no change in atomic number and mass number. It emits electromagnetic radiation, no charge. It travels with the velocity of light. When a neutron is bombarded with uranium atom, it breaks into barium and krypton. It occurs at ordinary temperature. In Kalpakam, Kodunkulam nuclear reactors are examples of nuclear fission. For fusion, it occurs in sun and stars. It occurs at very high temperature, approximately 10 power 7 to 10 power 8 Kelvin. Using nuclear fission, the temperature should be first increased and it is applied to the fusion reaction. The energy released in fusion reaction is greater than fission reaction. Elementary particles are simplest particles and it emits radiation. They are short-lived one. They do not emit under normal conditions except protons, electrons and neutrons only exist, but other elements do not exist. Four types of interactions are used for elementary particles. They are gravitational interaction, electromagnetic interaction, strong interaction, and weak interaction. Gravitational interaction depends on inertia. Electromagnetic interaction depends on velocity. Strong interaction occurs due to PION and KAON. They are strong one. Weak interactions, beta decays are best one. Bosons are the examples of weak interaction. The parameters required for elementary particles are: first one mass, second one particle and antiparticles. Examples of particles and antiparticles are electron and positron, neutron, antineutron, neutrino, antineutrino examples. Third one, quanta numbers. There are different types of quanta numbers: magnetic quantum number, spin quantum number, angular momentum quantum number, angular momentum spin quantum numbers, etc. Fourth one, strangeness. Fifth one, parity. Sixth one, charge conjugation. Seventh one, time reversal. In this table, photon charge spin is 0 and 1. Leptons, electron neutrino, muon neutrino, electron muon are the examples of leptons. Charge and spin values are given in the table. the value may be asked for the examination. In this table, hadron particles are given. It contains pi plus, pi minus, pi naught. They are called as bimesons or pions. Similarly, others k plus, k minus, k naught, k power, k bar or k mesons or kaons. Next one, eta to the power 0, that is called eta meson. The values are given as spin values, isospin values, strangeness values. All the values are given. It will be asked in competitive examination. Particles which are heavier than nucleons are called hyperons. They are divided into cascade hyperons, omega hyperons, sigma hyperons, lambda hyperons are given in the table. Similarly, the previous table, here also strangeness value, isospin values, all the values are given. Positive value, negative values are given. It will be asked for competitive exam. In addition to these, quarks values are also given in the last column. It will be asked definitely in the gate examination. So study thoroughly. Quarks contains three types, U, D, S respectively. It is given in the slide. The reflection operation of position coordinate is called as parity. Electron, proton, neutrons are having even parity. Mesons are having odd parity. Like, share and subscribe now. Thank you for